Good afternoon.
Afternoon, morning.
Yeah, morning here. I like your shirt. I think you've
Thank
worn
you.
that before. I like that salmon color.
It's getting to the heat out here where you need something loose to keep cool.
Yeah, break out the linen pants.
Yeah.
That's cool. What's the temperature? Oh, like we're gonna have to do our conversions.
I'm now doing conversion because we're just over 30 Celsius. So
Okay.
that's what, going into about the low 90s?
Yeah, I was gonna say I think that's 90-ish. Yeah. All right. Well, lucky for you. We're at yesterday. It was a cool one at 105.
Yeah.
Yeah, but like we talked about before, to me, I don't really mind. Hi, Nadal. Hi, Niall. I don't really mind actually the dry heat. It's when it gets humid.
Yeah.
Like when I go to Taiwan, I mean, even in May, it's not even really summer yet. It's just like I feel like I'm walking through soup, and I can't hack it.
It was like that in Florida where you're just standing there drenched.
Yeah, in Taiwan too. I mean, the first time I went there, I remember being like wearing a tie and a blazer, right? And uh, then just being like dripping with sweat and running into a little restaurant or whatever and trying to get ice, which is
Yeah.
not it's not a thing. So yeah, that was a good lesson. Don't leave home without a nice cold bottle of water.
Yeah.
Hotel room. Anyway, hi everybody. How you guys doing today? Welcome. All right, got our streams rolling. Hello out there in LinkedIn and YouTube land. Hello in the server. I better tell everybody in the server we're on. But today we are doing another in our embedded software decision series. So last week we spoke a little bit about bare metal and when you'd use bare metal and potentially not. This week we progress into the next logical step, which is real-time operating systems. How do you know you need one? When do you need one? And what do you do when you realize that you do? Before that, we'll get into introductions. My name is Brandon Lewis. I am a deep tech journalist. I've been doing this for, I don't know, 13 and a half, 14 years now. Really happy to be part of DevHeads and be able to put something together where we can share information, knowledge, and grow together. This is our agenda, but there we go. I skipped a slide. So, Zach, do you want to go next since you'll be the man of the hour in introducing yourself?
Hey everyone, my name is Zach. I'm based in Cape Town in South Africa, and I'm a software engineer, mostly working with embedded systems. Welcome to today. I hope to deliver a nice, informative talk or something, or discussion.
Ming, you're up.
So my name's Ming. I'm based over in France. Been working on Linux systems for over 30 years and playing around with embedded systems for over 15 years now.
Cool. Umesh.
Hi everyone, this is Umesh here. I've been building embedded software and hardware from past 10 years for IoT solutions. I'm based in Pune, India. Thank you.
Cool. Himal, how you doing?
Good, thanks. So yeah, my name is Himal. I'm originally from India, currently based in Dubai, and I'm a hardware engineer. And yeah, I've been making products for about I think last 10 years or so. Yeah.
Cool. All right. Well, actually, let's take a step back. Is anybody? Last time we were talking about at the very last second, one of the new server members, Marvin, said that he was working on a payment system, and it reminded me that we have a a tradition of letting everybody know what we're working on right now, or at least at a pretty high level. Ming, you said you were working on some healthcare stuff. I mean, I don't expect everybody to go like super deep into what it is, but you just want to share with what you're working on right now?
So I'm working on a system for dialysis patients,
Cool.
whereby there's a little wearable patch that's able to pick up a whole bunch of blood works based on optical sensors. And that is transmitting all of its data through to a little hub across Bluetooth. The hub picks that up, sends it up to the cloud, where it can be picked up and processed and then looked at by all the physicians to give feedback into the health of the patient in semi-real time.
And as a Linux developer, you're working on multiple parts of that system, right?
Yeah.
Yeah. I'm imagining the wearable patch doesn't run Linux.
That's the bit that doesn't run Linux. Everything else does.
Yeah. Cool. Umesh, you sell products, so you're usually working on the same thing. But what are you working on right now?
So we basically built, we have a product that basically connects to the PLCs, and our focus is more on the industrial automation. So our customers are basically the one who make the automotive parts, or maybe some sort of manufacturing where you have a CNC machines, you have a PLCs to whom you can connect your IoT device, IoT hub, and that pull the data and then process it further, sending to cloud, and then do all those, MES data presentations and all stuff.
Well, so we've got industrial IoT and healthcare IoT in the first two. Zach, what are you up to right now?
So we're doing metering solutions right now. We don't need like water and electricity metering solutions for the local government. That's what we're doing at the moment. We might get into like some water purification and measure like quality control, but we don't know about that yet. But yeah, at the moment, that's what we're working on. Cool.
In what way is it connecting back to whatever system it needs to connect to? Is it just over some like serial or control area network? Like, how are you getting data back to where it needs to be?
So most of the stuff needs to go over like Wi-Fi and stuff of the sort, and then it depends on what device itself that you're using. Like if you're building like something that's as a station, you could probably use something like Wi-Fi. But if you're building something that's remote, you're going to use some serial protocol of some sort, or like RS-45 to Ethernet or something like that.
Okay.
Like that's what I've said.
Awesome. Any LoRa or like sub-gigahertz stuff being investigated?
Maybe Marvin's the one who's doing something on that, but like we can't promise yet.
Okay, we'll ask Marvin in a second. Hemal, what are you up to right now?
Off work, I'm making a couple of projects based off ESP32. There's some products there, mostly IoT in home automation, and there was also one around GPS tracking for vehicles, like fleet tracking stuff. And at work, I'm looking at something into different stuff like how to do simulations and things like that, like using OpenEMS and Elmer FEM. So I'm looking at those side of things.
Awesome, cool. Vidal, you're on blackout mode, so if you want to say something, open it up, and I'll.
Oh yeah, hi everyone.
Hey.
So I'm Nidar. I'm from Tunisia. I'm based on France, and I'm working since 7 years in embedded software for IoT projects, making some IoT devices. And now we are working. I'm working in a semiconductor company. We are making some wireless microcontroller supporting BLE, ZigBee, Thread protocols.
Awesome. Wow.
So and now I'm working especially to support teams and customers on Zephyr subjects.
Okay. Well, you come to the right place. Zach, you and Zach should hook up in the server because we've got some content heading that direction. Marvin, hey, what's up, man? I kept saying I don't know what your name is, and Zach kept reminding me that it was Marvin. So sorry about calling you 32-bit over and over. Welcome.
It's okay. My name is Marvin. I work in payments, finance. So basically, what I do is build around payment systems for embedded Linux. And this week, I've been working on we have products that connect the embedded Linux payment systems to Windows machines. But now we have a client that wants the same, but connected to a Debian machine. So I've been working on doing serial communication over USB and RS-232 for communication between the Linux machine and the embedded Linux payment channel. Yeah.
Awesome. Well, that's great. Again, you and me, I'm sure we'll have some more stories to share at some point. I wanted to take the time to do that just because, there's some new faces in here and, we'll level set and everybody knows a little bit more about who everybody else is in the room. Usually we say we only have time to say hi, but we did a little bit more than that. We'll skip what we learned this last week because I know Zach's got a lot to go through. So today's topic is on RTOS. Like I mentioned back at the top of the broadcast, we are trying to determine when you need an RTOS, if you need an RTOS, and at that point, what you should do about it. So I'm going to go ahead and hand it over to Zach. Zach, I can just push the slides for you, if that's okay. And you're muted.
That should work.
Okay,
Yeah.
Cool. Take it away.
Okay, so yeah, cool. So I'm a software engineer at RTOS. We do embedded systems. We mostly tender for like local government stuff and try and find clients online. So about RTOS is the next slide. So the main aim of today's discussion is going to be introduction. Like we kind of want to explore when to sense that you need an RTOS, because could you do the next slide, please? Did you hear me?
This one or next one?
Anyway, yeah. I don't know. The next one, please. The start of the presentation.
Is this it?
Yeah. Yes.
Okay.
Cool.
Perfect. Sorry.
And I might move through them rather quickly. So, okay, cool. But so you're not going to go into, most of the times, you're not going to go into a situation unless you've done this before. If you've done this before, you don't, and you already need a real-time system, then you wouldn't, I wouldn't expect you to be looking at this. So when you're choosing a real-time operating system, it's when you realize you have a certain number of problems in your application. So you have things like, and I'll go through this in detail next, but you have things like real-time constraints, which means you have timing demands that you need like to wait a second or to wait a millisecond or to wait a certain amount of time before you do something. And it's critical that you wait that. And then you need predictable responses. And you need to be able to say some things are more important than other things. And then on top of all of this, you need your system to always do the same thing, like the expected thing all the time. You don't want it to go off the rails and do something else. So you can do the next slide. Let's go through details. Let's explain these things. So yeah, here's an example of like when an RTOS would come in handy. So this is showing an example of communication between engine control unit and engine. And this is, if you're like me, maybe you might be interested in vehicles. I really like vehicles, bikes or cars. And I always thought I would be able to like build tuning software for bikes and cars. And that's one of the things that got me into embedded. But like what this computer here is doing is trying to control the timing of the engine. The timing of an internal combustion engine is when like to put in fuel, when to push, when to push the piston, when to spark the fuel plug. You have to do these things at a very specific times. If you follow through this conversation, you'll see that the engine is trying to, is getting instructions from the computer on how to run, say, injectors in series or something. So you need to put in fuel, then you need to push in something, then you need something else to wait, you need an injector to wait, and then you need an intake valve to be open. And all of these things need to happen in a sequence, and they always need to happen in this sequence as many times as possible. So these are kind of the situations where you would need an RTOS. You have timing constraints. It's not that just you need simple delays, but you have time problems that are dependent on other time problems. And they need to happen in a certain order. Otherwise, you have what is described as catastrophic failure. We can go to the next one. So, cool. So, sometimes before we go into breaking down, looking into when you're needing an RTOS, sometimes you can identify when you're going for an RTOS, but you don't need to be going for an RTOS. As an example, I think Umesh did an example last office hours, and he explained how he had to rework a problem that someone used an RTOS. I think they were trying to use an RTOS as a way of using a library within the RTOS to control, like maybe some IO or something. And he had to rework this project and do it from fresh and do it without the RTOS because it simply wasn't needed. So if you don't have problems that are of this like timing nature, that's why real time is in the name, time series stuff. You don't need to reach for an RTOS. One of the common things that you need to start watching out for, so I would say, is like, once you start seeing you need a timer that is non-blocking and that it needs to hold several delays or several intervals across your application, then you start, if you find yourself building a timer that can be reused a number of times in your application, and there's times where the timer has more than one delay in progress, then maybe you might need an RTOS, but you could also fix some problems with just priorities. Okay, and then sometimes people end up using RTOSs like libraries. Some RTOSs come with HALs, really good HALs, and HALs are attractive to developers because they make everyone's work less. You can do faster, you can depend on open source software, you can depend on good, dependable code. And sometimes you'll end up using an RTOS when you're trying to do something simple, because the simplest way that is documented right now is using an RTOS. So that's usually the wrong time. Okay, now let's dive into how to sense the needs for an RTOS. Now you know you don't need an RTOS, or these are not the problems you're encountering. So we can go to the next slide. Wait, an example of, this is a commercial application by, I think, a company in India, and it's been in application for like quite a while, and they don't use an RTOS. So the thing I'm trying to explain here is, just because you're shipping something for the client or the end user to use does not mean you now need to graduate. The RTOS does not mean some people use the RTOS as the final layer of development. Like, now we're done, let's put an RTOS on it and then ship it. You don't need an RTOS to ship. You can ship without an RTOS and you can still ship the functionality you need. Okay, the next one. So, cool. Now, you can jump to the next one here, I think, quickly, because it's the same thing. So the first time I saw this list of things, this is how I felt. It's like, we're talking about inter-task communication. What are tasks? We're talking about memory management. Why do I need to do that? You have a memory management unit. You're talking about this time management that I'm talking about. There were so many confusing things. It sounded like I did not know what an RTOS was, why to use it, and it always sounded like either this is something, they're building something so complicated that I can't approach, or they're simply repeating something I can always reuse. So let's break these things down one by one and see how they applied and how RTOS help you with this. Next one. Cool. So task scheduling and priorities. Sometimes you need, like in the like in the slide in the beginning where the engine was speaking to the ECU, you would realize the ECU would say, the next thing I want you to do is probably fire a certain cylinder. But before you fire a certain cylinder, I want to schedule putting in fuel into it. And now, when you're doing this, you would probably schedule a whole firing sequence or a whole timing sequence in order to make sure that it happens in the order that you want. Now, that arrangement of things to happen in which order, that's the scheduling that you need. This is where you'll need an RTOS, which gives you features for scheduling as you need. Things can happen in a certain order, and they always happen in that order. So it's deterministic. You always know what will happen. You can expect that it will happen the way you arranged it. Okay, so the next thing is inter-task communications. So in that diagram, there was a point where the task that was feeding in the fuel needed to wait until the task that was pushing the something needed to had done so. And this is almost a method of back pressure. Don't do something until I'm ready. Don't fire the thing until I'm ready. Do you have that problem in your? Do you have that problem in your the solution that you need to wait for other things? And is it such a problem that you could solve it using something like interrupts? Because RTOS has introduced quite a layer of complexity and a lot of time in development. So you want to be careful when you're choosing them. So make sure you're not escaping something simple. Like in here, I probably mentioned something like sensor fusion, or where you need to mix information from many sensors. So maybe you're doing something like a smart wearable, and you need to develop something that can count steps and tell someone how long they walked, and you need to combine this into maybe some shape on the thing, maybe then, or something. But you might find that if you only need one of those delays, if you only are developing a pedometer, you don't need an RTOS for this. Okay, next slide, please. Okay, cool. Memory management. So you need to make sure, if you have an application that does sporadic data coming in, you don't know what size of it, you have many sensors of varying capacities, and they can send you many sorts of data. You might end up allocating your memory all over in patches and looking like you don't have enough memory. But this could be just you use blocks that are maybe too big or something, and you ended up overusing your space in some sort of way. So like FreeRTOS, which is an example of an RTOS, gives you mechanisms of choosing ways of how to fit memory. Like you could use something like a fast fit algorithm, where you go and you find the fast space that is big enough to accommodate this amount of data that you need to put in, and it could do that. So most RTOSs would come with configurations where you could choose between ways of arranging your data that suits your application best. So it depends on how you have data coming in and going out, and which kinds of buffers you need to maintain for what sorts of data. And if you need a very complex system that does this, RTOS makes that easier to do. Okay, time management. This is the one I've kind of banged on a lot. You needed to manage complex time delays or time associations. You need if something needs to be scheduled and then triggered at the right time so that the whole system is successful, then you would most likely need some sort of very deterministic timing mechanism, and which is most of what an RTOS is. It's a compilation of libraries that give you scheduling, timing, memory management, and tasks and task communication. Okay, what's the next one? I'm gonna push through. Yeah. So as is the case with like bare metal development, you still get mechanisms for handling interrupts in RTOS environments, and they now enable you to have interrupts that are of different priorities. And I think I covered this in one of the Zephyr threads or something, where I showed how priorities could interrupt each other, and if you could have a task of a higher priority could come in, like in this example, it's a robot with some robotic application, maybe a robot arm with an emergency stop button. If that stop button is pressed, that signal should be the highest priority. Everything should cease. Motors should not still get power once this stop button is pressed. So that's you still have mechanisms to do this in RTOSs. And then when you're managing shared resources, so here it's easy to, you usually hear words like mutexes and semaphores here. And a simple way to look at them is, so a mutex is a mutual exclusion. A mutual exclusion, some case of mutual exclusion. And a layman's way of putting that is you have resources that can only be used by one and only one, either person or task or thing. Say you have a screen and you have a thread that can show the steps per day, or the amount of water consumed per day, or the heartbeat per day, and you want to control those. Each of these can only show one. So now you're sharing that screen between, say, 3 threads or three functions. Yeah, let's call them functions because threads are functions here. Now, in mutual exclusion, only one of those would be able to use that screen at a time. And that's what a mutex is. So, and RTOSs come with this structures or concepts inbuilt so that you can just start using them. You don't have to define them, build a mutex, and then you can use them like in bare metal. And for semaphores are usually for handling pools of resources. Now, this was confusing for me at first. What are pools of resources? So say you have like an antenna that has a number of, you're doing some sound measuring thing, and you have an antenna that has maybe 5 or 10 microphones in an array. Now, a pool of resources is where you have that group of 5 microphones that can be used by your system. That is a pool of resources. Those are connections that can be used by your system. And in your system, you can decide to divide 2 of them for something, or 4 of them go for a most important task. But it depends on how you're using the group of resources inside your whatever application you're doing. And you want to do this without blocking, without like someone taking the resources forever, or without ending up in a situation where it goes like, I'm sure everyone here, yeah, we're in a remote call. Everyone has been in a situation where you go like, you want to talk, and Umesh wants to talk, and Ming wants to talk, and then we all stop talking because we don't know who's going to talk next. And you want that not to happen in your application, because if that happens in your application and your application is in charge of, say, something important like braking or like getting the plane off the ground, you're going to have catastrophic results. So, cool. Next slide, please. Cool. So, flavors of real-time operating systems. So we have FreeRTOS, which is, I think, one of the most popular ones. And it's usually the entryway because it's open source, it's free, you can get started. It's free as in free beer. You can use it as you wish, and you don't have to attribute to them, or you don't have to change your licensing. You can license your code as you wish by using FreeRTOS. So it's a good one. It's very skinny, it's very small. Most people would consider FreeRTOS a beefy scheduler. It's just most of what an RTOS system is. Like if you're needing real-time operating system features, you want the scheduler and the things that come with the scheduler. And quite a lot of RTOSs come with things like HALs and stuff. And sometimes you use the RTOS because you want to use the HAL, and you could end up in problem. We've seen that happen quite a few times. So there's also Zephyr, growing in popularity, new, and comes with a really good HAL. It's very big. It's very big and open source. That's why I would say. And has a big community active that people are developing. So that's pretty cool. And it's very easy to get started with. But it feels easy to get started with. Like you can blink stuff really quickly, way quicker than say bare metal. But I find like once you start digging into like doing say like the other bigger protocols, you need to still end up modifying the existing drivers for the particular variation of machine that's on your desk that you're working on with. So it's easy to get started with, but you'll need to the learning curve does not seem that steep, but it gets steep very quickly. It's almost like it's hidden. The chapter 3 or something becomes the learning curve goes up. And then there's RTEMS, which is mostly popular for like, I think, medical and flight stuff. And it's also open source and free to check it out. Then we have VXWorks from Wind River, and I think they are a software consultancy. They make really battle-tested software. I think their slogan is something like, when it matters, it runs Wind River or something. Well, I don't know. They seem to make good software. It's really good. It's very expensive, but it works. It works for very big projects. They've got space applications, so that's cool. Not that FreeRTOS doesn't, or the others don't. It's everything else. Let's look through some factors that you would use when you're choosing an RTOS. Okay, next one, please. So think about what your application needs. Sometimes you just need a scheduler, and you already have a complete application, and you can put a scheduler in it because 2 new tasks got defined, and you need to have some real-time scheduling for them. And for that time, you could use FreeRTOS. Sometimes you're starting from greenfield, you're going to use a board that has a huge community on, say you're doing something like 2.4 wireless, and you're going to do some Wi-Fi halo application, and you're going to use something like the Zigbee as access point, or the NRF 52 development kit as a base. Then you use that. Then you're going to most likely choose Zephyr or something of the sort. So it all depends on what your application needs. You have a safety critical application. You're building something. You ended up getting a missile defense system, and you have to build it now. You're probably going to end up going with VXWorks of some sort. So hardware compatibility. So most of these boards, most of these RTOSs have a compatibility that goes, it is compatible with N compilers, and then compatible with M microprocessor or microcontroller architectures. And then you would look through the, what is it? Is it the product of that, and see what is available for you? So they have large coverages. So you want to know what your hardware that you're going to release with, develop with, if you're going to have a multi-stage process. You want to know what it is compatible with, and which compiler are you using? What are you using to develop? I mean, if you have a team that's already on IAR or something, or it's already on ARM GCC, and you want to use that, you choose an RTOS that has a compiler for that. The next 2 factors to consider. Oh, yeah. So I find finding community support or commercial support. So this, like, Brandon made me aware of this. So like, you're probably not going to find community support for VXWorks, because you're not going to find tutorials for VXWorks, because Wind River is going to give you those, and you're going to find them in the Wind River community. So, or support system if they have, or one of the sort. So, and then, but for all the others, and for most of the rest of software, you want to look at what, how much of a community exists that you can leverage. You don't want to end up using an RTOS, and then because you use this RTOS and you're so dependent on it, you end up having to maintain it, because now no one else is using it. You have a product that's on this, you have to maintain this, you've already shipped, you can't change. what happens? You have to maintain something so that you can use it. So in the early days, when you're choosing an RTOS, it's always good to choose something with a good sized community, with an active community, with a welcoming community. I don't know if that's a thing I can say. Okay. And then the next one, time to market. Like, familiarity is good for development because you finish faster. You know the gotchas. You know where not to go because you'll get hurt if you go there. You know if things, you know how to do things, and you can plan better because you've done it before. So time to market is going to be key. When you're choosing something, you'll want to choose something that allows you to go to market as soon as possible, rather than something you have to learn from scratch and go for it. Maintenance. This goes with time to market as well. So choose something you're going to be able to maintain. I kind of touched on community support. You don't want to choose something where you end up having to maintain your product and the operating system it's running on, because those are two different concerns. Like an RTOS developer that makes RTOSes and an RTOS developers that makes real-time applications do very different things and have to think about very different problems. So like you don't want to end up having to take on the burden of maintaining something that you're using. So consider this when you're choosing an RTOS. I think, yeah. So that's probably most of what I wanted to cover today. Sorry if I've pushed it and tried to rush it too quickly. I wanted to leave as much time as possible for questions, and I already see some in the chat. But the next time I'll be doing one of these, we'll cover design, task design, efficient use of system resources, debugging and testing techniques in respect to RTOSes. And if you want to get more context on what I've done, you can refer to the previous office hours on Zephyr threads and priorities. I see some questions already, and I think I can.
Yeah, real quick. I do want to point out that we're gonna do a follow up. So we had put this together, but the topic ended up being bigger than we thought. So it's like, let's chop this in half, and we'll get a second office hours that goes through some best practices here. Right now, we can jump into some questions, but I also want to note that we've got a couple of engineering hour sessions coming up on FreeRTOS and a couple more after that on Zephyr. So you'll those sessions dive deeper into the actual application and use of the technology instead of these like conceptual overviews. But we do have some questions over here, and I'd like to get feedback from not only Zach but others who've used RTOS, and what your thoughts are and what you would do in these certain situations. Ajay Kumar says, "How do I decide task priority?" Well, again, I think that sort of depends on your application, right? So I pushed him a little bit, and he said, "Well, if I've got a UART, Wi-Fi, and Bluetooth, and an application layer, how do you decide task priority in this context?" And maybe it might be better reframed as saying, how would you implement something like a task priority in this context? And can you also talk about something, Zach, called priority inversion, and some of those like hurdles that you might run into when working with an RTOS?
Yeah. Okay. So it's not as clear cut as Ajay would want to. It's not like I can tell you this is the one that is the most important protocol that you must follow in your application. Like, what are you measuring? And if this measurement fails, will it make the thing that you were paid to do fail? That's the thing that is that gets the highest priority. Which operation when it fails will be very consequential to you. So that's kind of how to think about it. It's not about thinking like, oh, I have this 3 and these things could happen. It's what spoils the result of the application. I think I kind of explained it right. And then there was a second part of the question, Brandon, sorry.
Yeah, so I talked about one of the things here that's interesting is when you start talking about priority levels.
Priority
so,
inversion, yeah.
On the engineering hour last time, we talked about implementing priority, which you do not need an RTOS for necessarily, right? It's
Yes,
you
yes.
start using RTOSs when your system becomes complex enough that you need a lot of things are happening at once, and you need to set a bunch of priority levels. But there is implementing priority in a complex way, and then weird things can start happening in the RTOS land, like priority inversion. So priority and then priority inversion, if you could speak to those things.
Okay, cool. So we kind of covered priority, but like I said priority is importance of tasks or operations. So logging, say, okay, I have in the if you want to rush back to the engine communication thing, and then we'll see.
Yeah,
there's an example. There's a really good example there. But so say like it's more important to control how much fuel is going into the engine than to log out that I have sent fuel to the engine. Those two, say you are the system that had to do those two. So it's more important to send the fuel to the engine than it is to send the message out that you've sent the fuel. So that's the kind of priorities. One thing is more important than the other. One thing has a higher priority than another. Okay, priority inversion. And Ming shared a really good link there. But a simple way of doing it is imagine a situation where you have a very important task, but you have a very important task that needs to happen. Like say this putting fuel into the chamber for combustion. But this putting fuel into the chamber for combustion needs to wait for the UART logging service to release UART so it can talk to something on the other side of a UART connection. It needs to wait for that. So it lets the little thing, it lets the logging thread take over and finish logging so that it can take over. But in that time, because the logging thread is a very low priority, let's say it's a priority of like 0 and the injection is a priority of 5, maybe some 3 thing happens. So something like open the exhaust valve, which is a little less than fuel, but it's more important than logging. So if it says open the exhaust valve, this task could take over the computing in such a way that the thing that is sending the fuel waits, and that could end up exploding like your engine. So that's priority inversion, is where like a mid-level important thing takes over a high-level important thing, but not directly through the high-level important thing needing a low-level important thing to finish. That was so convoluted. I don't know if it made any sense.
No, it does. And actually the reason that I set that up, because this is a more advanced thing that will happen to you. But the reason that I bring this up is that sort of this entire series of sessions that we have here are, do you need to do this, right? Do you need to select a real-time operating system, really? And one of the questions I put in here is, you made a really good statement. Oh, FreeRTOS is like a beefy scheduler. Okay, well, at what point, you can write yourself a scheduler, right? At what point does it make sense to go from writing yourself a scheduler to using an RTOS? Because you're going to, some things will be easier. You'll have a lot of more documentation, a lot more support, a lot of like things you can pull off of Git, right? But you also have, the flip side of this, where you can get yourself into trouble potentially by overdoing it with something you don't necessarily need. So, like, where would you say, okay, I now have gone from the point of needing to just write my own scheduler to now I need a real-time operating system?
Okay, I think I'm going to take a risk here, and I'm going to give a short explanation, and then I want Ming to talk a little bit and explain something. And I think he's going to have good examples. But as you when you start dedicating development time to the timing, or like, oh, our timer is broken, it's doing not well, or our scheduler is not scheduling well, then this is time to offload it and give it to something else. But you might be able to get away with a very simple timeout schedule. Okay, I think Ming and then Umesh.
What I'd also be looking at is how many things are you scheduling? If you've only got 2 or 3 things, writing a simple scheduler, yeah, that's easy enough. The more complicated your system is getting, then I know I work on the concept that there has been a lot of research put into schedulers, deterministic schedulers, how do you create them, by people far more intelligent than me. So I'm going to leverage their ability when it starts getting into 10, 20 things I'm scheduling. That amount of complexity, I want to have a beefy scheduler.
For sure. And Umesh, I mean, we had this session last week about when to use bare metal and not. At what point, and also another important thing is Zach talked about HALs, or hardware abstraction layers. I mean, there are hardware abstraction layers that you don't have to have an RTOS to get a hardware abstraction layer, right? So from your perspective, Umesh, at what point do you say, oh man, STM32Cube IDE has, a bunch of provisions in it, right, to allow me to push, the limits of what I can do without an RTOS. So at what point do you say, all right, like now it's time for me to move into RTOS?
So personally, let's say if I'm working on a project, then I would see if my code complexity gets bigger. Okay, and I'm working with a lot of concurrent tasks, right? Which there are two ways you can see. One is when you write a code, and if you avoid using RTOS, then how complex your code base looks like. Because there's not always like you need RTOS just because you need a real-time behavior. Sometimes I ended up using RTOS because I just want things to be quick. Something what Ming says, it's ready, so I can just quickly use it, even if I can able to write scheduler, but I don't want to do it because somebody else have written it and I'm not better than that somebody else. Maybe they are the big team and I'm a small company like HP printer, building a small printer. So I think I would see the complexity of a code and then how the size is. And if I'm an employee, let's put it myself as the shoes of an employee. If my manager says I'm okay with using RTOS, then I would straight away go and use RTOS, right? So that is how I would see. Yeah.
Maybe you're a small software consultancy like Wind River.
Yeah, it's too big for Wind River. Let me share with everyone how it happens to me, how I in my personal life understood, okay, I need RTOS. So I was writing a code, basically building a prototype, and I was ended up writing code where I'm using a lot of millis function. Those who write Arduino code, they know there is a millis function through which you can able to do a little bit of multitasking. It's not a real multitasking, but a kind of multitasking. Then I moved to bare metal where I was handling an interrupts. Now, I think in last engineering hour, I spoke, even if you have a lot many interrupts, you will not use it because it gets too complex as a design. Software designs get too complex. And once you hit that, then you still get to see this behavior in your code that you may be missing out, the timelines, or maybe the resource that you want to share, the variable value that you want to share between a different task for functions, that is missing. So unpredictable behavior starts coming up, and that is where you realize, okay, I did the best of my abilities. I wrote a state machines and the memory management, event loop, everything is perfect, best of the technical ability, and now I'm still having this behavior where I'm just missing out maybe timelines or memory or something. That's where I then, and then again, I would not quickly go into commercial RTOS. I would look for something which is very easy, let's say FreeRTOS. So it's not really RTOS, but it's just a scheduler. So if that can able to do it, then I would probably do it. And if I need more advanced stuff out of the box, then I would then go for commercial RTOS. So that's how there are steps in it as you start building application.
Umesh, follow up for you via Ming. How does the use of an RTOS affect the power consumption of your device? Have you noticed, when you're straddling the line, like it's like, oh, now I have to rethink, other parts of my design because, the power consumption is greater.
Yeah, absolutely. This is very important topic. Unfortunately, I don't work so much on battery operated these days. But in the past, of course, for home automation, you have to put something inside the wall, and that's not very convenient. So you run on a batteries. But that's why I think we have to leverage the commercial RTOS, because some RTOS are designed to optimize the power. So there's not one solution to all the problems, but as we start using RTOS is basically an kind of hell abstraction layer, which is what I think even Zach has mentioned. It's like an bare metal hell, and then you put more layer and the development get easier and easier. So I think then you go and choose uh, the RTOS which power optimize. And one thing though is important is, like, some OSs, because their footprint is very small. I think that's what Zach also referred to. So all together will impact your power consumption, your functionalities, and everything. Sometimes you might need an RTOS footprint which is very, very small because you want to. Your microcontroller itself is a power optimized. That is also one thing. Not all RTOS port will be supported to your RTOS. Maybe you're planning to use some RTOS which doesn't have support for your microcontroller, right? So I think it's again very complex question to answer, but yeah, it matters.
I'm going to play devil's advocate and ask, how long is it actually going to matter? Because honestly, with how inexpensive memory continues to be, right? It's like, yeah, I mean, power consumption is an issue, right? But the fact is, like, we started talking about, I was talking to somebody the other day who said their company's building a development kit, and they want it to be super low power, right? They do vision processors, or AI processors for the edge. And they said, oh, we're doing it on FreeRTOS. And I was like, oh, have you considered using Zephyr? And they said, no, because it's too big. And I was like, okay. I mean, understood, kind of. I mean, but if you're using a development kit and the objective here is to get as many people to develop on it as possible, you might want to consider doing both. Or, Zephyr had 100,000, reached the 100,000 commit plateau a couple of days ago. I mean, the thing is exploding. So the point being, I think the time to market pressures, I think the availability of developers, right? All of those things in the long term really start factoring more heavily into your decision than they have in the past. I'm not saying that they completely outweigh, some of the power constraints depending on what the system is and et cetera. But, over time, when you go look for what we were talking about last week, assembly programmers, right? When you go look for how many assembly programmers are there available and how many people are there available who know how to develop on top of Zephyr or FreeRTOS, your decisions are going to maybe be made for you. So good stuff to consider. There's one last question for you. It's a little bit more on the potentially complex side. So Ajay Kumar asked again, what is the difference between message queuing and semaphores?
Yeah, I can dig it in. I also did it in writing. So message queuing is when you need to, you need to get information from three sensors. You need temperature, you need humidity, and then you need let's make another random one, some infrared thing. Three little sensors. You need them, but the amount of information you're getting, one gives you 16-bit, one gives you a 8-bit, one gives you 24-bit, but it's 32-bit, and something is like masked, so it's not really whatever. So you have these sizes of data coming in, multiple variable sizes of data. But you, in the end, your aim is to do something like make a CSV file that can be uploaded to some IoT service so that it can, it can be used for someone and someone else. Not your problem. So you need a CSV file, and you have a SD card to make this CSV file. So the way you would use a queue to hold these messages as they come in. You would, like, for this period, for this second, the thing that I measured is this, and a queue would be able to bug those three differently sized bits of information while you wait for them all to write the line into your file that you save. A semaphore is when you have a group of resources that you need to share cleverly. Something like, I use an antenna example. So you have, like, you are listening to audio and you have 15 microphones, but you have this thing that can tell you whether audio is coming from the right side or the left side. And this is just a use case I'm bringing up off my head to make it simple, because the actual use cases are even simpler, but if I say you just need it for connection pools, no one understands anything, and I'm not making the point. So you have, say, a number of microphones, and they can be used by a number of functions. The one processing the middle of the operation, the one processing the sides of the operation. And imagine you're building some LiDAR or radar map or something. And you can decide if you want to point the giant microphone made of 20 microphones, you want to point it all to the right, you can decide to take a big group of them and point them to the right or whatever. So when you have a group of resources that you need to manage and share in your application, like a number of, say, buttons, sensors of some kind, but you need to share them intelligently. Now you use something that's called a semaphore. They can be counting, they can be binary. It's like either someone is using all of it or not, or someone is using 5 of them and you only want them to use 3 of them, something of the sort. So I'm trying to make it like as simple as possible. Yeah, I wonder if that answers my question to Ajay.
I think, honestly, one of the best ways to demonstrate this would be during an engineering hour session. Yeah. I think showing it and showing the difference is probably a better way than like explaining it, because we're starting to get into like super abstract concepts. Not that you did a bad job. I think you did a great job, but it's easier to like show and tell, I think.
Yeah.
For something like that, you need pictures.
Yeah.
Yeah. I should have gotten more pictures. I see another question. Soft RTOS or hard RTOS? This is just differences in deadline. So a soft RTOS or soft real-time application is when a delay is acceptable. You have a keyboard, and if it delays a couple of characters and then blats all the things out, that's okay. No one's going to die. Developer's going to get mad. They're going to delete the line and do it again. That's fine. But you have a braking system and it forgets to brake, or it forgets to measure when the wheel is locked and it doesn't check, and it lets your anti-lock brake system actually lock the brakes and the car slide into the next car in the front. You don't want that. That's catastrophic failure. That's a hard RTOS system. So if that's good examples.
All right, we got 2 minutes left. So Ajay, appreciate the questions. Keep them coming, but put them in the server and we'll get to them as we can. All right, so we went through all this. Community questions, help your fellow dev heads. A few here. We did a great job cleaning up some of the ones we had on last time. There was a big backlog, and we got those addressed. Some stuff here on 18 mega and Zephyr, and then some other x60, x86 stuff here. Oops, I forgot to put Camila's question in. So sorry about that. I'll update that. And yeah, so if you guys can check those out, I'll upload the slides, and you can jump over and find what your colleagues are struggling with. Next up, next week we're going to do Introduction to Embedded Linux. Ming's going to be explaining the difference between Yocto, Pokey, and Open Embedded. If you don't know the differences between those three and you're trying to do some sort of embedded Linux, you should probably join. Then after that, we're going to go into bare metal versus RTOS versus embedded Linux roundtable. This is a session that I'm picking some applications and some use cases, and I'm going to throw them up to the panel and see what they think of what they should use, what you should use in a given situation. Now, after this, I had the start of a product development lifecycle series, but because we split this RTOS section, I'll talk to Zach and the rest of the guys and see if it makes sense to get the rest of this session slid in there on the 6th before we proceed with a new series. Next engineering hour this Sunday, Cystic Timer, talk about RTOS. This is a timing function in Cortex-M devices that essentially implements an automatic countdown that kicks in an interrupt when you get to 0 and then restarts itself. So this is the type of thing that you, if you're building up towards using real-time operating system, Cystic Timer is a session that you'd want to check out and figure out, hey, maybe I can do this with or without an RTOS. Then later, Zach's going to be continuing. Like I said, there's going to be some content here around you doing some actual stuff in engineering hours with FreeRTOS, some more hands-on, sort of applied technology. So check those out. You can see in the server there's a channel called Engineering Hour. Just click it and join. Then there's some other kit reviews in process, and then some videos that we are doing on, we call them Ask a Developer, and we've already pushed out a couple recently around embedded memory. I think there's another one on building your own power circuit. So check those out. Oh, actually, real quick, Hemel had a question about what firmware developers think about MicroPython. They don't think it's a real thing. So they think it's for playtime. Just wanted to make sure I got that in for you, Hemel. That's it for today. Slid through pretty quickly there at the end, but I think it was a great session. Thank you so much, Zach, for your insights and taking the time to put that presentation together. I think it's a great foundation for us to build on top of. And everybody else, grain of sand, appreciate you bringing yours this week. And we will see you next week. The next meeting is not on 6/28. It's actually on 8/23 or 23/8. Sorry for those of you who are not in the US. 23/8. Thanks everybody. Really appreciate it. I hope you have a good weekend.
Cheers, everyone. Thank you.
See you.
Thank you. Bye-bye.
Bye.